Here is a small mechanism about the formation of cloud droplets. The water vapors in the atmosphere needs a particle. So water vapors are present in the gaseous state in the atmosphere, but they need a particle. This is what is called as the cloud condensation nucleus. When the particle is present, they stick onto this or they condense on this particular particle. So this leads to the formation of cloud droplet, and this further condensation lead to large cloud droplet. So let us look at some of the important aerosol characteristics. The size and the chemical composition of the particle evolve with time through coagulation, condensation and chemical reactions. That's what we say. Some of them are formed by the secondary reactions. So that means secondary aerosol formation is basically some chemical reactions, and the primary one is basically from the coagulation and condensation reactions. The particles may grow by uptake of water, a process that depends on chemical composition, particle size and ambient relative humidity. As we say, when there is a presence of brown carbon or marine aerosols, depending on which type of the aerosol that is present, it may lead to more absorption of water. That means they will be getting converted from the hydrophobic to hydrophilic nature. The different particles have varying impact on the atmosphere depending on composition, and the numerous sources and the large size in the distribution further complicates the quantification of their effect. This is what we have seen earlier also. The cloud albedo effect is very difficult to measure. The reason is they are not uniform. They have heterogenic in nature. Cloud formation is basically heterogenic in nature. So that's the reason we will have different size of the particle, type of the particle, and their nature is also quite different. So it's very difficult to study the cloud albedo effect in the Arctic region. And basically the particle act as the cloud condensation nuclei if they are larger than 40 to 100 nanometers. The ability of the particle to act as a cloud condensation nuclei also depends on the particle's hygroscopicity, because we know the cloud condensation nuclei has to absorb water molecules. So it is already saturated with water, means more water molecules. But condensation may lead more larger size of the cloud droplet. That's what we have seen in the previous mechanism. Both particle growth and the mixing of different particle types influence the climate effect on aerosols. Let us look at the impact of aerosols on the cloud properties. See, the aerosol particles act as the cloud condensation nuclei and the ice nuclei. So they have a significant impact on the cloud properties and precipitation, because when there are more moisture, then there is a possibility that they can condense and they may form rain. So that is the reason the precipitation is related to the amount of ice nuclei present in the cloud. An increase in the CCM, that is the cloud condensation nuclei forming aerosol in the cloudy region, produces more but smaller cloud droplet. This reflects more solar radiation to space, leading to a cooling effect on Earth's surface. This is known as the first indirect effect or the cloud albedo effect, which we have been discussing earlier also. So the smaller droplet suppresses collision coalescence, requiring longer growth time to reach the raindrop size. So this increases the cloud albedo and enhances the cooling effect. This is known as the cloud lifetime effect or the secondary indirect effect. In contrast to in a saturated and a buoyant environment, an increase in the cloud condensation nuclei forming aerosols can invigorate the cloud through microphysical processes, but there is a significant uncertainty in such impact. Let us look at the global aerosol budget. The direct radiative effect or DRE is absorbing and scattering incoming solar radiation. So this magnitude and the relative division between absorbing and the scattering will depend on both the particle size and composition. The peak efficiency for scattering and absorbing solar radiation are typically reached with particle size between 100 nanometer to 1 micrometer in diameter. The second one is cloud albedo aerosol indirect effect or AIE. So it is the aerosol's ability to alter the reflectivity of clouds by changing properties such as cloud droplet number concentration or CDNC. Typically, these particles act as a cloud condensation nuclei if they are larger than 400 to 100 nanometers. The ability of the particle to act as a cloud condensation nuclei also depends upon the particle's hygroscopicity. So based on these two things, we can actually measure how much is the aerosol budget in the Arctic region as well as global region. Apart from that, we also have biologically productive ocean which emits volatile organic compounds, primary biological particles, primary organic particles and halocarbons. So these are also responsible for some of the secondary aerosol formation because the halocarbons are important for the ozone layer depletion. So similarly, they also affect the secondary reactions which are responsible for the formation of aerosol. The sources of marine particle often indicate that organic species present that could dominate submicron aerosol mass, and sulfur containing organic compounds in the form of dimethyl sulfide and organosulfates are important precursor and contributor to marine aerosol. So these are all the minor contributors to the global aerosol budget. Here are the schematic representation of what are all the effects we have discussed. So we have different types of aerosol particles. So what are all the different reactions that are happening is given here. Various hydrocarbons undergo oxidation to produce, say for example, nitrogen oxide, sulfur oxide, ammonia. All these undergo oxidation to produce sulfuric acid, nitric acid and organic aerosol. These are responsible for the nucleation of aerosols, and soot also leads to black carbon. Dust particle is also responsible for the formation of aerosols, and isoprene and terpenes are emitted by the plants also undergoes oxidation. And we also have forest fires which are also responsible for the formation of soot and volcanic particles. Sea salt leads to the formation of marine aerosols. Phytoplanktons release dimethyl sulfide which undergoes reaction to produce methane sulfonic acid. This is a second chemical reaction that is occurring for the formation of secondary aerosols. Then volcanic eruption. So all these reactions lead to the formation of aerosols, and they leads to the formation of cloud, and the cloud actually affects the surface albedo effects. Let us look at the relationship between aerosols and the climate. The first one is all atmospheric aerosols scatter incoming solar radiation which results in a cooling effect. They have a dark surface. So this is one type of mechanism or a process that is happening. And the second one, there are other type of aerosols. They can absorb solar radiation, for example, black carbon, mineral dust and some organic carbon components. This results in the warming effect. That means they have actually a bright surface. So these are all the two types of aerosols that are present. And now let us look at a different type which is exactly opposite of these two. That means if the scattering aerosol has a bright surface, then what will happen will be they will be less efficient because here the solar radiation is reflected because they have a bright surface. On the other hand, if the absorbing aerosol has a dark surface, then the light will be absorbed because dark surface absorbs radiation. So these are exactly opposite of the first two what we have seen. So depending on the surface, whether it is a bright surface or a dark surface, that leads to absorption or reflection of solar radiation. So absorbing aerosols are particularly efficient when they are positioned above the clouds, which are a main contributor to total reflection of solar radiation back to surface. So this is a very good one because they will send back the solar radiation. Absorbing aerosols basically alter the air temperature, causing an increase in the lower level static stability. This inhibits the convection, which leads to a decrease in the cloud cover that is known as the semi-direct effect. So these are all the various ways by which the aerosol affects the climate. Let us look at the direct aerosol effect and the cloud albedo effect. So here we have two types of aerosols. One is the scattering aerosol, another one is the absorbing aerosol. We also have two different surfaces. One is the low surface albedo effect material, another one is a high surface albedo effect material. So it is nothing but these are snow, this can be considered as water. So these are all the two different type of material that are present on the land. So when the solar radiation hits the scattering aerosol, part of the sunlight is reflected because it is being scattered by the aerosol. But when the same solar ray falls on the absorbing aerosol, nothing is reflected, but some of the thing is absorbed and the rest of the thing is passed to the surface. So when we talk about the surface, the low surface albedo absorbs all the sunlight that falls on it. And similarly, whether the sunlight passing through the absorbing aerosol or a scattering aerosol, it doesn't matter. The low surface albedo effect material absorbs all the solar radiation falls on it. And if you look at the high surface albedo material, it reflects anything that falls on it. So if you have a scattering aerosol, solar light passes through it, but most of it is actually being reflected back. So in that case, what happens is whatever is falling on the high surface albedo is also reflected back, and the scattering aerosol again reflects back most of the things to the atmosphere. When we have the absorbing aerosol absorbs solar radiation, and when the part is falling on the high surface albedo, again the absorbing aerosol absorbs whatever is coming to it, and it only reflects small amount of the solar radiation back to the atmosphere. So in other words, the scattering aerosols actually are the good one. They keep the temperature low, and the absorbing aerosols are actually leading to the warming of the atmosphere because they absorb most of the solar radiation. And when we talk about the same thing on the cloud, so we have a cloud with lots of aerosol particles. So we have two different things. One is the unperturbed one and the other one is the cloud albedo effect. So in these two cases, what happens is the unperturbed one reflects most of the solar radiation to the atmosphere, and the cloud lifetime effect also is responsible for sending back most of the absorbed solar radiation back to the atmosphere. So the cloud albedo effect is actually a better thing for keeping the atmosphere at lower temperature.